Oh, hello. I didn't see you there. I was just working in my favorite programming language, Scratch. Now, Scratch is a great beginner language because of the way it has code in blocks, and it connects your code specifically with the sprites that use it. Now, we're not programming in Scratch. We're programming in my second favorite programming language, Python, but we're going to be learning the basics of object-oriented programming, which has the same idea of compartmentalizing code to make it easier to think about working with. The motivation is that we'll organize it in a meaningful way that can be scaled easily, and we'll do that using classes. Classes are essentially blueprints that allow us to create objects based on this blueprint called instances, and repeat and keep making new instances over and over again for different I guess instances, of these classes. And so one example where we would need something like that is if we were working with all 30,000 students at UConn. There's going to be similar information for each of them, and we're going to be doing a lot of the same actions to all of them. And so we'd make a class for that. And so we'll make a class called Husky. And for now, I'm just going to write pass here. And we're going to add more stuff inside of this class. But by writing pass, we're telling Python, hey, I know this is blank. It's cool. I'm coming back to it. I'll get to it. And so I'm going to create a new version of this class called student1. And to create a new version of this class, essentially take this blueprint and create an instance of it, we add these parentheses to the end. And so if I print student1 and I run this, you'll see that it prints out that we've got this Husky object at this location in memory. Now what if we create another student? What goes on there? You might guess, and you'd be correct, that it creates a new object, a completely new Husky at a completely different place in memory. And so these two Husky objects, despite being made from the same blueprint, are actually completely different things. And so now let's start adding some information to our Husky object. And so every Husky has a name, and so we could assign a name this way. And this name is, and adding this dot and then this variable name is what's called adding an attribute to this Husky object. And so my name's Finn, and my year of graduation is 2022, and I got a fly nearby, that's why I just clapped. And my email is definitely finn@uconn.edu. Definitely try emailing me there. It will work, I promise you. And so now, if we want to print one of these attributes, we print it as such, the same way we assigned it. And you can see that now it printed my name. And if I change this to year, now it prints my year. And so this is cool. We've got our attributes assigned to our Husky object, but this seems like a lot of lines to write every single time we want to define each of these things. So now I'm going to show you a way of creating these attributes as soon as the class is made. And so the way we'll do that, and I'm just going to show you first, and then I'll explain everything piece by piece. I'll write def, and then init with these underscores, and then the word self, and then all of the attributes we want to add. So we want to add our name, we want to add our email, and we want to add our year of graduation. And then in here I'm going to write self.name equals name, and likewise for the other attributes that we're going to add to this function, to this class, equals year. And so now if I save this, and actually the next thing we've got to do is when we create our Husky, inside of these parentheses, much in the way that we do for functions, we will pass all of these three, the name, the email, and the year, variables. And so the email, again, will be definitely my email, and then the year will be my year. And so now if we run this, you'll see that this ended up working. So now I'm going to go back and explain what all of these things are. So dunder init. This is what's called a magic method, as opposed to a regular method. A magic method has underscores on both sides, and that is a way of telling the programmer that this is going to be a function that Python uses internally. And the place that this dunder, this magic method is used, is dunder means double underscore, by the way. It's just shorthand for that. The way this initialization method is used is when we create our Husky object. It takes all of the things that we put inside of the parentheses here, and then runs the initialization method and gives them to this method. And so the next thing we got to sort of explain is what this self guy is. The key with methods in Python, which are sort of like functions but specific to certain classes, is this self variable. And so the first variable that's passed to any method in Python is self. And self refers to the instance of our class that is currently running. And so when we run create this Husky, this is actually replacing, you can essentially think of it as replacing each time this says self with student one. And so it's going to take student one and plug it in all of these places. We could create another student the same exact way. If we do student two, we make another Husky and call him Mike. Gee, I wonder who that guy is. And uconn.edu 2021. And it will do the same exact thing. And now if we check student two, it again will print that year. And so to recap, what happens is we create our new class, we give it the parameters we want to pass, and then Python runs dunder init, which we define right here, and it accepts all of our attributes that we want to add, and then assigns the attributes to our instance of this class with the self variable. One thing to note is that when we pass through these variables, name, email, and year, they can be named anything. For convenience sake, we're naming them the same thing on this side as of the assignment statement as we are on the other side, but they can be named whatever the heck you want. So N, E, and Y, everything still works the same. And that's just one thing to know, is that these are different things. And likewise, with self, you could change self to just S. And I wouldn't suggest doing this, because generally when you're working with Python, you always write self as the first parameter, because whenever you read Python code, it's nice to have nice for the instance to be referred to as the same thing. And so everybody sort of agreed that self is what we're going to use for that. And so to keep your code from being too confusing, just use self. But know that any variable name we apply in this first argument location is going to be the reference to the instance of this class that we're working with, regardless of what it's named. But we use self almost always. And so now we know how to add attributes. And again, afterwards here, we could add student1.major equals CS. And then if you do have specific attributes that are specific to one instance of a class, you could add them this way. But and it looks like I'm referencing student 2 there, which, as you can see, doesn't have this attribute major. But student 1, since we just define it, it does have it and will output it. Generally, though, when you're working with when you're working with classes, you want to be benefiting from the fact that all instances of a class have the same attributes and can be referred to the same way. And so now I'm going to show you how to make your own methods. We just created a method here, this magic method, dunder init, but we can add our own methods as well. And so one thing, and actually real quick, I'm going to add back these names here just to make sure my code is readable for anybody who uses it. One thing you might want to do with all of the students at UConn is have a description of them, and so we can create this method the same way we would make a function, but it's inside of this class declaration. We can create this method called get description, and what will the one parameter that we'll have for this is self, because this method is going to be referring to self and all of the attributes associated with the specific instance of this class. And so I'll write, let me write this, and then I'll get a little bit more into that. And so if we return a description, I'm going to do an f string again, and we can say self.name graduates in self.year. And so now, when we want to get this string of information specific to any one of these instances of Husky, we refer to the instance, which in this case will be student1, and we say get description. and just parentheses, because since we're not including any extra, since we're not passing anything besides self, we don't include anything in these parentheses. Self is always hidden as the first parameter, and any new parameters you add will be added after self. But the first parameter in any function will be self. And so if we run this, you'll see that it outputs my description, which is Finn graduates in 2022. But what if we don't include self here, just for argument's sake? If we don't include self, then it's saying that it takes 0 positional arguments, but 1 was given. And that 1 that was given is the reference to the instance. It passes through student 1 into the parentheses by default, but we don't actually assign it to anything. So the error we're getting right now is what the heck do we do with this instance that we're supposed to be passing? And so you always do need self right here in order to assign the instance to some variable. And so now, as you can see, that we're referencing each of these things inside of the get description method. I'm going to make one more method just to show off one more thing you can do with methods, and it's going to be get full description. And this is going to be sort of an extension of get description. And what we're going to do now is we're going to return self.getDescription plus, and we'll say a space, and then email them at plus self.email. That's what it is. And so now what I'm showing off here is that you can even use methods that are defined within other methods that are defined inside of your class, which is good because it means you can apply. Sorry, let me think about how I want to say this. You can grow upon previous methods that you've written and add new things that are already based on what you've already written. The same way you would with functions, where you write a few functions and then use those functions in your other functions. And so now down here, if we write get full description, you will see that it gives us all of my information. By calling get description, getting this string, and then adding this extra information we added to that string to it. And we can also do the same thing for student 2, Mike. And so now we'll get information for both of these students. And so that's the very basics of classes. You can create attributes for classes, and you can create methods for classes. When you want to use a class, you create an instance of it, which takes the blueprint of that class and gives it the information you explicitly want to use. And then you can use that class throughout your code. And this is great. Now we can create as many students as we want. We could run a for loop and put all of these students into a list, and then have a list that has all of our students at UConn in it, which would be pretty cool, because then we could just run through a for loop and run like get description on everything in that for loop and have descriptions of every single student in UConn in a very concise fashion. But I'll show you more about functions inside of the next tutorial about object-oriented programming. This gives a pretty good outline. And if you have any questions, feel free to reach out to us at UPE, and we'd be happy to help you. Anyway, have a great one, and thank you so much for watching.